Alrighty, so for example 11, we're asked to graph these three things given that we know what the graph of ln is, which we just previously did. So all I'm going to do is write out the differences, and then I'm going to show you on Desmos what they look like, okay? So the difference in example A is this positive 3. It's on the inside. The inside means it does some weird stuff, so it can do the opposite of what you think, and we're going left and right. So it's plus 3, which means we're going left 3, okay? So if we were to look at that on a graph, essentially, we were originally at this 0, 1. Oh wait, no, I'll just do it on the Desmos calculator and show you guys. Okay, so originally we had ln x. Okay, so ln x looks like this. Okay, and now if we do ln and then do x plus 3, that means we're going to move to the left 3. So it's that blue graph. Okay, so it just shifts to the left by 3. Okay, and then for B, let's talk about our differences. If we go from the closest to the furthest away, we'll start with this red one. So this 1/2 is connected by multiplication. It's on the outside, so we think height, right? So it has gotten twice as small. Instead of having ln x, we have half of ln x. So this is going to be a vertical shrink. Oops, I can't spell. Shrink, okay? And then next we have this negative. This negative right here is connected to the y. Remember, our y is our function, okay? So this ln x is our y. That's our function. So this is affecting our entire y. So that means we flip over our x. Remember that? So if it affects y, you flip x. Okay? And then last we have this 3. This 3 is on the outside. Don't be confused by this negative. This is a positive 3. So this is going up and down. So that means we're going up 3. Okay? So now let's look what that looks like on a graph. So the red one is just ln x. And now I'm going to do ln x and do 1/2. So you see the blue one is the 1/2. So that's a vertical shrink. So it just came downward to the blue one, okay? Now from the blue one, I'm going to take that equation and then tack on a negative. So when we tack on the negative, it's going to flip over the x-axis. So this blue one right here is going to flip. This is going to flip downward, and that one's going to flip upward, okay? So now we have the green one, okay? And now from this green one, I'm going to put that 3 in the beginning, and that's going to shift it up 3. So this green one is now going to move up 3, and that will be the final answer. So this purple answer is the final one, okay? Alrighty, and then last for number 3, C. For 11C, we have the absolute value of the natural log of x plus 3. This plus 3, so on the inside, it is going to do the opposite. It's attached by adding and subtracting, so it's left and right. So this is going to go left 3, which we've already established on part A. And then these absolute values are different. And absolute values, they make your y's or your function positive, okay? So essentially there's going to be nothing in quadrant 3 or 4, okay? So essentially, because these y's are negative, you can't have anything in either of those quadrants. So if there is something down there, let's say we had a graph like this, it's actually going to flip over the x-axis and then move itself upward, okay? And I'll show you guys what that looks like right here, okay? So again, we have our ln x, which looks like this. And now we'll have our ln x plus 3, which is going to shift it to the left. So that blue is going to shift to the left. Okay, now it's green. And now this green one, I'm going to apply the absolute value. So the issue with the absolute value is this green, is this line going down, is this little curve going down, right? So essentially all it's going to do is flip upward. So let's see that happen with the next color. So the purple would be the final answer. You see how it just shifted that green upward.